So our next session is the stack question type demo from Chris Sanguin from University of Edinburgh. And this one's a little unique because this is something that's actually not in Sakai, but we're looking to see if folks are interested in integrating this as part of the Sakai tests and quizzes tool, similar to the way that it works in Moodle. So if you are interested in having this be a part of Sakai, please let us know in the chat as you watch Chris's presentation. So I'll turn it over to Chris whenever you're ready.
Thanks, Wilma. Hi, everyone. Thank you very much for including me and for your welcome. I'm Chris Sanguin. I'm a member of staff in the School of Maths at University of Edinburgh, UK. We're a little bit past lunchtime, but that's all right. I'm going to talk about the stack question type, which is some software that I've been developing since about 2002. Which has large communities, but not yet in Sakai. So if this is something which is interesting to the Sakai community, then we can talk about how that can be integrated. So let me just explain what I'm up to by showing you what's going on. Okay, so I hope that's all sharing nicely.
Yes.
Given time, I'm just going to very briefly show you what the tool is and describe it. With 10 to 15 minutes of time, we really don't have any time to talk about how we are developing the tool to take advantage of AI, but that is all going on. It's actually really exciting, and we have got some major AI assessment tools in the pipeline and almost ready to release. So I'm very excited about that. All right, so what is it? Basically, stack is a question type for mathematics. I'm in the maths department. I teach maths. That's my interest. And what does it do? It generates random questions. The answers are mathematical, so the student has to type in a mathematical expression. We interpret the meaning of that expression, and then we check for mathematical properties. And then on the basis of those properties, we give various outcomes. So those outcomes are formative, which is typically text to help the students. Those can be summative outcomes, which is a score or a mark, which goes into the grade book. And then evaluative outcomes would be data about what the students have done. And I've been working on this for a very long time, more than 20 years, nearly 25 years. And I really think that assessment is the most important part of education. It's when students bump up against the work, it's how we help them, it's how we find out what they know. And ultimately, those of us who are in institutions that examine, that's the means by which we decide whether we've been successful. And so I've always focused on assessment as the most important thing. That's not to downplay the importance of giving good lectures and talks or writing books and materials. Those things are all important as well, but actually the assessment is the thing that I'm focused on. So what's wrong with multiple choice questions? I know in North America there's a real tradition of multiple choice questions, but in maths they have a real problem. Actually, I can't speak for other subjects, so they may have real problems in other subjects, but in maths they have a particular problem. And it's guessing, or worse, reverse engineering. So one of the problems is guessing, right? If you choose an answer to a question at random. But also, particularly in maths, we have reversible processes. So for example, multiplication of numbers versus prime factoring of integers, or we might have laws of exponents and laws of logarithms, or we might expand the brackets, or we might factor, we might write an expression in single fraction or partial fractions, we want to differentiate and integrate in calculus, and so on, right? And typically the direct method, the direct method, you know what to do, you can always do it, and you just get on and do it. The inverse process is often much more difficult. So for example, writing an expression in partial fractions is much more difficult than just combining fractions into a single fraction. And symbolic integration is notoriously much more difficult than differentiation, right? And so the problem with the multiple choice question in this context is that no sensible student would do the inverse process. What we want students to do is the difficult inverse process, but actually no sensible student would do that. They would take each of the choices that you've given them to select from, and they would apply the direct process to the choices instead of the inverse process to the question. So that's kind of a notoriously difficult. Now, there are ways of writing clever multiple choice questions, but I'm interested in actually having the student do the work and give me the answer. So that was the kind of principle. So we need specialist tools, and we have those specialist tools. Probably every subject does, but I can only answer for maths, so here we are. But we have these sophisticated tools, and again, a whole other talk is about having tests worth teaching to. We're in a real period of change where you can point your mobile phone camera at a mathematical problem. The AI, the optical character recognition part of AI is essentially flawless at this point. So you get a digital object to work with, and then you can use a different kind of AI to get a full work solution. So there are really good questions about what we teach and why. I'm not going to get into any of that today, other than to acknowledge that's a really important question that as a community we need to answer. But anyway, today is about a particular tool which I'll just show you. So we have really rich features, algebraic input, multi-part questions, random generation, sophisticated feedback. We do support multiple choice questions, as I will show you, because they certainly have their place. We have full support for scientific units. Stack is used very widely in nearly every European country. So 2/3 of German universities use Stack. I think every university in Finland still uses Stack. Finland's interesting because in many institutions, the students can choose their language of instruction. So their materials are often in English, Swedish, and Finnish, and the student can just choose. So one individual learning object will support multiple languages. We have right to left languages, including Arabic and Hebrew, and we have a large Japanese user community. So we're pretty on top of the language thing. Line by line reasoning, string input. I'll explain why you need proper math support for string input. We have drag and drop items, and you can have graphical input. So the student can drag a graph, and the configuration of the graph will be their answer, right? So all of those things are included. So let me just show you the tool. And this is in Moodle. I'm sorry, I'm not a Sakai user. I chose Moodle many years ago. I'm very glad that I chose something and I stuck with it. I would have never got this far without Moodle, but we're not restricted to Moodle, as I will come on and explain in a minute. But my contribution is the blue box with this very boring calculus question in it. This is a typical kind of calculus problem. And let's just get it sort of wrong. So the first thing to notice is that it interprets the answer. The student's answer is a mathematical object and it interprets the student's answer. And there is some notion here of validity, right? So nobody wants to penalize students on a technicality. And so the teacher has to decide so some things validity is just always the same, right? If you miss a bracket, I can't make sense of your answer. It doesn't make any sense. So that's kind of obvious. So you have to get a syntactically valid thing at some level, but then there are some choices about what might go into validity. So for here, for example, I have forbidden floating point numbers because students use floating point numbers as an approximation, and then that really messes up the marking algorithm. So if you really want an exact answer, you can forbid some things. Okay, so let's imagine I have got a answer that is valid. And now this quiz is set up for immediate feedback. There are different quiz options, but that's not really my concern. You can use this as an exam context with feedback that's delayed, but here I'm doing immediate feedback. So here is the feedback the system gives. And if you're a mathematician, you'll know what this question is asking. And here is some feedback. The derivative of your answer should be equal the expression that you were asked to integrate. That was this. In fact, the derivative of your answer with respect to this, so you must have done something wrong. Yeah, so we have taken the student's answer. We have done a non-trivial calculation, the derivative of your answer. We have decided that it's not correct, and then we have given some feedback. So if I actually get this correct and do something like that, in this context, I am allowed to have another go. So let's have another go. You need to add the constant integration. So there's something there. So we have constant integration, and there we go. So that's basically Stack. And now the rest sort of is features. So before I go on to show you other features, let me just show a little bit behind the scenes from a teacher's perspective. So we do generate random questions, but we have found over the years that it is much better to pre-generate random questions, to thoroughly test them, and then to give the student a selection from a pre-tested list. This means we can bulk test questions in advance of the student getting them, and we can just check that they're all the same difficulty, that they're mathematically possible, and so on, right? This is a bitter experience of running this for many years. It is much better not to generate things on the fly, okay? And then we have unit testing of questions. So here, that gets a score of 1, and we expected a score of 1. And I said there were statistics. There are these notes. So these notes allow you to do statistics across different randomizations. So for example, if you miss the constant integration, you get this note. So by counting these notes, I can see how many students have missed the constant integration, regardless of which random version they've got. So that's the kind of all behind the scenes with the random generation, the unit testing, and the analysis. I am going through this quickly because there's a lot of sophisticated stuff behind this. I mentioned we had complete scientific units. So this is a multi-part question that demonstrates scientific units. So let's imagine you push a car along a bench in a physics class. How far did it go? It went 2 meters. Well, all right, we need at least 2 significant figures. So I decided here I need enough information from the student to make a judgment. So I'm going to go for 2.0 meters. How long did it take? 4.0 seconds. And what was the speed? It was 0.5 meters per second. And again, 2 significant figures. So there we go. And it decides that, yes, your calculation is consistent with the speed that you measured. So we actually look at how this question is authored. This is a multi-part question. Each part is an input, and then the student's answer is assigned to a variable. So you have D for distance, T for time, and then answer 1 for their speed. And then the algorithm that assesses that, we have to declare scientific units, but then the algorithm that assesses that, is their speed actually tested against evaluating their distance over time? The point of showing you this is that there's no unique answer here. We're actually taking the students' 3 answers and doing calculations and deciding if, in the context of scientific units, they are suitably close to each other. Right? That's what's going on with that. Let's get rid of that. Let's get rid of that. And I'm running short of time, sorry. So I'm going to skip this one. For the pure mathematicians, give an example of an even function. So let's do a sine of x. And let's just show you this. It really is calculating f of x minus f of minus x is non-zero. So you must have done something wrong. So we really are establishing mathematical properties. We can do line by line reasoning. Let me just show you what that looks like. I'm not going to just do this question. If I just fill in the correct response, just being lazy in the interest of time, the system can establish the student's line by line working is correct. So that's the kind of thing that can go on there. So we really do have, I'm not going to go through all of these things. This site is open for people to come and have a look at. So one of the things about Stack is that it's basically a stateless function of the current input, right? So there are some numerical penalties for previous attempts, but we don't store the history of students' attempts. Outside Moodle, we have an API which is widely used inside bespoke exam systems. So somewhere here I have the API running. So if you want to look at the drag and drop questions, for example, the function, its derivative, oh, that's not right. So that's going to be the function. The derivative of that one will be a straight line. So you can do this kind of drag and drop. That's the API with the drag and drop question types. We have open textbooks. So we have a big project in Kenya. They are producing open textbooks for the whole country. This is an example from their draft of their open textbooks on quadratics, and you can see my my question type is embedded in this. I'm not sure if this is going to work today because this is all development code. There we go. But something like that. So that is, there we go. Oh, and I got it wrong. All right, fine. It's probably plus, isn't it? But that's the open textbooks. We have large question banks. So Stack is distributed with over 3,000 battle-tested questions. And there's a major German question bank project. So that really, I mean, I'm over time. I'm sorry. we have a community website, which I'll leave up. There's the demo site you're welcome to log on to. That's the API. And I hope that's useful for the Sakai community, that we can use that to embed. And that's my email address. And I should stop there before I try everyone's patience. So thank you for your interest. And I hope this is the start of the conversation.
Awesome. Thank you, Chris. I know it was a lot to cover in a short amount of time, so you really only whet our appetite to learn a little bit more. But hopefully there'll be some interest from other folks in the community. I know we had some interest from some of the institutions in Africa that were probably introduced to it via the Kenya project with the open textbooks. So hopefully we can get this something that we can integrate into Sakai either as a question type, the way that it works in Moodle, or as an LTI, as Chuck suggests in the chat. Those are all options. But I encourage you, if you're interested, to go to those URLs that Chris provided and check it out a little bit more to see what it's capable of, because it's a very sophisticated system.
Well, thank you for your welcome and for including me. And please do contact me. I'll post those links directly into the chat before, as soon as this talk's over, and then people can follow that up in your own time.
All right, great. Thank you so much for being here, and feel free to stick around, as I know it's late for you, but feel free to stick around as long as you'd like the rest of today's agenda. So we're going to be on break for about 4 minutes, actually 3 minutes, and then we'll start back up with the multi-tool Forge presentation.